So in this problem, we are trying to find sine of theta if we're given cosecant of theta. So big thing is we got to recognize that cosecant is the reciprocal of sine. So if we're going to do that, all that's going to do is turn this, we're just going to flip it. So it's 2 over square root 99. All right, now most likely that is not the final answer. That's not an okay way to leave your answer. You have to rationalize the denominator. So at this point, you have two different options. One of them is you can see if you can find a perfect square that you can take out of this and make the numbers a little smaller. So the number might be a little smaller to rationalize, or you can just kind of rationalize it now and then just deal with the fact that we're going to have to simplify later. No matter what, you're going to have to simplify. Okay, so let's say we go I'm going to make it a little smaller route. So I'm going to do a little side work of the square root of 99. Okay, I can break that into, I want to find a perfect square that goes into it, and 9 is a perfect square that goes into it. So I can break this into 9 and 11. They're still square roots because we haven't done anything with it. I'm just breaking it up into two separate square roots. This one, I chose the 9 because I can square root it, and then I still would have 11 sitting there. So that just means that this turns into 2 over 3 square root 11. Okay, now we have to still rationalize the denominator. So it's not the 3 that's the problem, it's the 11 that's the problem. So to rationalize it, we're going to multiply top and bottom by the square root of 11. All right, and we do that. We get a 2 square root 11 on the top. And on the bottom, this becomes the square root of 121, which is 11. So we chose 11 because it guaranteed us a perfect square, so we can actually square root it. And then I can put the 3 and the 11 together by multiplying. And we get that. And because I kind of simplified it first, the only thing left that I potentially would simplify would be the 2 and the 33, but there's nothing that goes into it, so then I would be done. All right, if I went the other route, it's totally fine. So if I took this 2 over the square root of 99 and said, I didn't even think about simplifying it first. So then that's okay. We'll multiply by the square root of 99. And I don't know what that is, but I know for a fact that it's going to create a perfect square that is just going to turn into 99. Okay, now it's the top that I have to work with. So it still goes back to the fact that I still have to simplify the square root of 99. It's still going to turn into exactly this same value. So this time the 3, so it's going to turn into this. Right now this is 2 times the square root of 99, so it's going to be 2 times the 3 square root of 11 over 99. And then I can put this together, 6 square root of 11 over 99. And then now I can take a 3 out of both of them. So that turns into 2, and that turns into 33. And so I still get that exact same 2 on top, square root of 11 over 33 on the bottom. So it doesn't matter the route you go. At some point, you're going to have to simplify no matter what. And if you recognize that you have a perfect square here, it might make it a little easier, but that even if you don't, that's fine. Somewhere down the line, you're going to have to simplify the fact that you have a square root of 99. All right, hope that helps.